Well, welcome to this online revision session for AQA M2, in which we'll be looking at the June 2011 question 6, which is on kinematics involving differential equations. Well, as you can see in this question, we have a car of mass m moving along a straight road, and at time t it has a speed v. As the car moves, it experiences a resistive force which is given as 2mv to the power of 5/4 newtons, and there are no other forces acting on the car. Horizontal forces, sorry, obviously vertically there would be. So, first part we've got to do is show that dv by dt equals this expression. So what do we know? Well, we know that force is equal to mass times acceleration, which could also be written as m dv by dt. And we know that that force is equal to minus 2mv to the power of 5/4. So we can say that m dv by dt is equal to minus 2m v to the 5/4, and so if we then divide through by m, we get dv by dt equals minus 2v to the 5/4 as required. Just one mark. Basically the key part is showing that the m dv by dt equals minus 2mv to the 5/4, and that's the statement that gets you the mark. Then you're told the initial speed of the car is 16 meters per second, and we've got to show or find this expression for v. So from the statement that we've got, it's the standard method for solving this differential equation, which is to separate the variables and integrate. So if we bring the v to the 5/4 across to the other side, so we would get v to the minus 5/4 integral dv equals the integral of negative 2 dt. We then integrate this. If we increase the power by 1, we're going to get v to the negative quarter, and then we've got to divide by that new power. So dividing by negative a quarter is the same as multiplying by 4, and that will equal minus 2t when we integrate the 2 with respect to t, plus some constant. Now, in order to find that constant, we know that when t equals 0, v has to equal 16. So if we substitute in, we're going to get minus 4 times, well, v to the power, v equals 16, so 16 to the power of a quarter is 2, it's the fourth root, because 16 is 2 to the power of 4, but it's a negative, so that makes that a half, and that will equal c. So our value of c must be negative 2. Okay, so that now tells us that we have minus 4v to the minus a quarter equals minus 2t minus 2. So if we multiply through by negative 4, that tells us that v is equal to negative a quarter v to the power of negative a quarter equals a half t. In fact, I can write that as a half t minus 1, or plus 1, sorry. Yeah. And so then to finish off, to get v, we got to do this to the power of negative 4. So we've got to do the 4th power and turn this up at the same time. So what are we going to get? We are going to get, well, the t plus 1 times a half, we can think of that as t plus 1 over 2. So when we do it to the negative, we're going to get 2 over t plus 1. And then we need to do that to the power of 4. Yep, and there we are, and we're finished. So where do our 5 marks come from? Well, our method again of separating the variables in order to solve the differential equation, obtaining this answer, will give you a mark. Then substituting t equals 0, v equals 16 will be a method mark at this point, and obtaining the value of c accordingly will give you a mark, and then rearranging to find the expression in terms of v gives you the final mark that you require. Well, hopefully you found that solution helpful. For further assistance with your maths revision, please go to the Further Maths Support Programme website.